Hello students, this is Harish Konda. Welcome to my channel, the Chemistry Classroom. So what we are discussing about the balancing of equations. In previous videos, already we discussed about hit and trial method and oxidation number method. Today we are discussing about ion-electron method. It is also called off-reaction method. With this method, we are balancing the chemical equation. So before starting the chemical equation balancing, I request you all, please watch up to the end and don't forget to subscribe, like, share, comment and subscribe compulsory, and that bell also. And here I am going to start the topic. The method is called ion-electron method. The method also called off-reaction method. So why it is off-reaction method? Generally what we are balancing the equation is redox reaction. That means it is a combination of two reactions. The one is oxidation, the second is reduction. So to balance this chemical equation, what we are doing? Very first, we have to divide the equation into two. The one is oxidation and one is reduction. So we have to divide this equation into two reactions. One is oxidation reaction, the second is reduction reaction. So actually this reaction is redox reaction. It is a combination of two reactions. And here we are separating into two. That means you are offing. So you are doing off, and the equations, the oxidation reaction and the reduction reaction individually we balance, and when we combine, automatically what you get? The complete balanced equation will get. That's why the method is called off-reaction method. You are dividing into two and you are balancing, and after that balancing you are adding completely balanced equation. You are getting the stoichiometric equation you are getting. That's why the method is called off-reaction method. It is also called ion-electron method. Why? Because the atoms and the charges also balanced with this method. The ion-electron method can balance the atoms. At the same time, the charges also balance. That's why it is complete balancing of chemical equation. With this method, you completely balance the chemical equation. So, what you have to do? We have to divide the reaction into two. The one is oxidation and reduction. So, how we are going to divide? Now we see. So, very first, you have to calculate all the oxidation numbers involved, the atoms involved in the reaction. Very first, you have to calculate all the oxidation numbers of each and every element involved in the chemical reaction. It is the first step. So here you see MnO4 minus. So you know already the oxygen always it is -2. So from here you can calculate the manganese oxidation number. How it is? MnO4, that is you are getting minus. So that means the total oxidation numbers, the sum of oxidation numbers is equal to -1. So here manganese you don't know, so X plus oxygen is always it is -2. How many oxygens you have? 4. That equal to -1. So from here X minus 8 equal to -1. From here 8 minus 1 that equal to +7. So here the manganese oxidation number in this reaction is +7. Before the reaction is +7. Then I minus. The I only single element and it is having the charge, it is -1. So in this reaction the iodine -1. The I is -1. Then after the reaction you are getting MnO2 and I2. So I2 is the element, it is a molecule. So the molecule is having 0 charge. And here the oxygen always it is -2. So you have to calculate the oxidation number of manganese. How we are calculating now? You see, it is MnO2. Manganese you don't know, so it is X plus oxygen is -2. how many oxygens you have? 2. So the molecule is having 0 charge, so it is 0. So x minus 4, that equal to 0. From there x equal to plus 4. So in this reaction, manganese is plus 4. So the total elements involved in the reaction, we calculated the oxidation numbers. So here the reaction completely we calculated oxidation number. The first step is done. Then you observe one thing. So what it is? In this reaction, two elements are changing their oxidation numbers. So one is increasing the oxidation number and one is decreasing the oxidation number. Now you observe before the reaction manganese is plus 7. After the reaction manganese is plus 4. That means the manganese oxidation number is decreased. At the same time, before the reaction iodine is minus 1. After the reaction iodine is 0. That means oxidation number is increased. So that means, so what happened here? The two elements are changing their oxidation numbers. One is decreasing the oxidation number and the other one is increasing the oxidation number. The increasing reaction is called oxidation reaction and decreasing is called reduction reaction. So here I am separating the equation into two. The one is oxidation and second is reduction. So what is oxidation? Increasing of oxidation number is oxidation. So it is I minus 1 that gives rise to I2. This reaction belongs to oxidation reaction. Why? Because before the reaction is minus 1, after the reaction is 0, that means it is increased. So I minus that gives rise to I2, that is oxidation reaction. MnO4 minus that gives rise to MnO2, it is a reduction reaction. Why? Because before it is plus 7, after it is plus 4, that means the reaction number is decreased. So it is a reduction reaction. So what we done? So the first step is completed. So the first step, the every element oxidation number we identified, we calculated. After the oxidation numbers, we separated the two reactions, oxidation and reduction. So it belongs to off reaction, That's why the method is called off reaction method also. Oxidation reaction is the off reaction. Reduction reaction is the off reaction. When you combine these two, the total reaction is redox reaction. So now we separated these two reactions. Now we have to individually balance these two equations. Then when you add, automatically you will get the balanced chemical equation. So individually these two reactions I am balancing. In 4 steps I am balancing. So what is the first step? Now you see, excluding of oxygen and hydrogen. Excluding of oxygen and hydrogen, the remaining elements you have to balance. So what is the first step? Excluding of oxygen and hydrogen. The remaining elements you have to balance. So here it is I minus that gives rise to I2. Here we don't have oxygen and hydrogen. So what I am doing? The excluding of oxygen and hydrogen I am balancing. So here before the reaction we have only one iodine. After the reaction we have 2 iodines. So what I am doing? 2I minus that gives rise to I2. That means the remaining elements are balanced. Here after the reaction we have 2. So I multiply with 2. So 2I minus that gives rise to I2. The first step is completed in off reaction. There also we have to balance. Here this side we have only one manganese. That side also we have only one manganese. That excluding of oxygen and hydrogen, the remaining atoms you have to balance. The remaining is manganese. The both side we have the manganese only one. So the same reaction I am writing MnO4 minus that gives rise to MnO2. The two sides manganese are having the same number. So the same reaction I am written. So here, so what happened the first step? Excluding of oxygen and hydrogen, the remaining atoms we balanced. Now what I am balancing here, the oxidants I am balancing. Why? Because very first I excluded the atoms. Now we are balancing the atoms. So very first I am balancing the oxidants. So here we don't have the oxidants. So I am writing the same equation as it is 2I minus, that gives rise to I2. Here I have to balance. Before the reaction we have 4 oxidants. After the reaction we have 2 oxidants. That means this side the 2 oxygen atoms are less. So we have to balance. In this method, to balance the oxidants, what we have to do, with which side the oxidants are less, that side you have to add the water molecules. What we have to add? We have to add the water molecules. So here I am doing, so it is MnO4 minus, that gives rise to MnO2. This side, how many oxidants are less? The 2 oxidants are less. So that's why I am adding 2 water molecules to that side. So to balance the oxidants, what I am adding? The water molecules I am adding. So here it is MnO4 and MnO2. This side 2 oxidants are less. So I am adding 2 water molecules to balance the oxidants. Now the oxidants are balanced. This side 4 oxidants. This side 2. In the water molecule 2. That means 4 oxygen molecules are balanced. That is your next step. So very first the atoms excluding of oxygen and hydrogen we balance. The next oxygen atoms we are balancing. To balance the oxygen atoms, which side the oxygen atoms are less, that side you have to add the water molecules. And next, third step, what it is, you have to balance the hydrogens. So this side we don't have the hydrogens. So I am writing the same, it is 2I minus, that gives rise to I2. So here this side, before the reaction we have MnO4 minus, this side MnO2 and 2H2O. That means manganese are balanced, oxygens are balanced, but this side we have 4 hydrogens. So what we have to do? To balance the hydrogens, which side the hydrogens are less, that side you have to add the H plus ions. So how many H plus ions we have to add? This side 4 hydrogens we have. So this side I am adding 4 H plus ions plus MnO4 minus, that gives rise to MnO2 plus 2H2O. To balance the hydrogen atoms, so what I am doing? So which is less, that side I am adding H plus ions. This side 4 hydrogens I have. This side 4 H plus ions I added. So the hydrogens are balanced. Now we see this equation. Here the iodines are balanced. Here the manganese are balanced. Here the oxygens are balanced. And the hydrogens also balanced. What it means? The atoms are balanced. But the charges are not balanced. Why? Because here this side you see the manganese is plus 7. This side the manganese is plus 4. You are not balancing the charges. The charges are not equal. So when the charges are equal, that means the reaction is balanced reaction. So in the fourth step, we have to balance the charges also. So with that, the atoms and charges also balanced. Then only the reaction is called complete stoichiometric reaction. So here you see, before the reaction I have minus 1. So after the reaction it is 0. So how many minus 1 we have? 2 minus 1 we have. So that means it is minus 2. It is 0. So what happened here? The product side, the I2 side, the charges are high. How many charges are high? 2 charges are high. It is minus 2. This is 0. That means this side 2 charges are high. So where the charges are high, that side you have to add the electrons. So how many charges you have? That 0, it is minus 2. This side you have 2 charges high. So what I am doing here, I am adding 2 electrons to that side. I2 plus 2 electrons. So each electron is minus 1. 2 electrons I am added. So it is minus 2 and 0. 0 plus minus 2, it is minus 2. This side also minus 2. The charge is balanced. So similarly, this side you have plus 4. This side you have plus 4. Plus 7, this side you have plus 4. That means 3 units are high to this side. So what we have to do, where the charges are high, that side you have to add the electrons. So how many electrons we have to add? 3 charges are high, 3 units are high. So you have to add 3 electrons to this side. So what happened? 3 electrons plus 4H plus MnO4 minus, that gives rise to MnO2 plus 2H2O. So what happened here, you see? This side you have plus 4, it is plus 7, but minus 3 is added. 3 electrons added means minus 3 added. So minus 3 plus 7, it is plus 4. Now the charges also balance. Now these equations, the half reactions are completely balanced. The atoms are balanced and the charge is also balanced. Now we have to add these two reactions, then only you get complete balanced equation. But here what happened, you see? So when these two reactions are added, this product side you are getting 2 electrons and the reactant side you are getting 3 electrons. The electrons you will get in the reaction, but the electrons are not appeared in the reaction. So we have to cancel the electrons. How we cancel? So we have one method. So here the 3 electrons, the 3 number I am multiplying to this one. Here the 2 electrons I am multiplying to this equation. So here what happened? 3 into 2 it is 6I minus, that gives rise to 3I2 plus how many electrons you have? 6 electrons. Similarly the 2 I am multiplying to this equation. 2 into 3, 6 electrons plus 2 into 4, 8H plus 2 into MnO4 minus, it is 2 MnO4 minus, that gives rise to 2 into MnO2, 2 MnO2 plus 2 into 2H2O, it is 4H2O. Now we can add the reactions. Why? Because here the both sides the electrons are equal, so we can add the reaction. So automatically these electrons are getting cancelled. So now I am adding these two equations. So the reactants first I add, then the products I add. So this side the reactants are 6I minus, and so this side the reactants we have plus 2 MnO4 minus plus 8H plus, the reactants totally added, this side 6I minus, 8H plus and 2 MnO4 minus, that gives rise to, so the products it is 3I2 plus 2 MnO2 plus 4H2O. Now this reaction is called completely balanced equation, that is stoichiometric equation. The atoms are balanced and the charges also balanced. Here you see 2 Mn, this side also 2 Mn. So here 2 for the 8 oxygens, 2 to the 4 and 4, that is 8 oxygens. So 4 to the 8 hydrogens, this side also 8 hydrogens. So 6 iodines, 3 to the 6 iodines. That means the reaction completely balanced equation. The atoms are balanced, at the same time the charges also balanced. So this method is called Ion-Electron Method or off reaction method. With this method, so very first we are dividing this reaction into two. The one is oxidation and reduction. The individually the reactions are balanced, then we combine that equation, so automatically you are getting the balanced chemical equation. So these steps if you follow as it is, you can balance the chemical equation. It is a complete method to balance chemical equation, and everybody don't forget to watch up to the end. Why? Because it is very useful to your examinations. So further knowledge, it is very important. At the same time, don't forget to subscribe. Please like, share, comment and subscribe. Don't forget to bell. Thank you.